Okay, we're going to address this infinite sequence here, a series 2n, 2 over n minus 2 over n plus 3, n equals 2 to infinity. If you were to engage this individually, probably would be something finding divergent. So we're going to have to do something a little special with this. The first thing we're going to do is factor the 2 out. And that way we at least have a little less of a job to do. Just slightly improve our work here, reduce it by doing that. But this sequence is still going to be a problem. 1 over n, minus 1 over n plus 3. It still seems to be divergent, but it actually is convergent. And you can actually find the sum of the sequence relatively simple, especially with these where you have one term subtracting the other. We can do some matching and pairing and show how that the pairs come off. So what we're going to do is partial sums. So talk about some partial sums for these. So we'll do like a partial sum, and we don't have to change the index, we'll just start with 2. And if we do that, we'll get the partial sum of this part right here. We're going to keep the 2 outside. So that'll be 1 over 2 minus 1 over 2 plus 3, 1/2 minus 1/5. And that's our first partial sum. And we can just continue that, make a list, and see how this goes. So our next one is be 1/3 minus 1 over 3 plus 3, 1/3 minus 1/6. Do the fourth one, the fourth partial sum, 1/4 minus 1 over 4 plus 3 equals 1/4 minus 1/7. You can see the fifth will be pretty straightforward, 1/5 minus 1/8. The sixth one will be 1 over 6 minus 1 over 9, and so on. So you get a pretty good idea of the partial sums working that way and trying to see how that adds up. So what we're going to do with this is we're going to look at the partial sums as we go through it. So we're going to look at the sequence or series n equals 2 to infinity of that Sn of the partial sums that we did. So that would actually just be a list. So we'd get the 1/2 minus the 1/5, and we can group that together, and then the 1/3 minus the 1/6, and group that together, and then the 1/4 minus the 1/7, group that together, and keep going, and we'd get 1/5 minus 1/8, 1/6 minus 1/9, and we would keep that going and going and going until we got to the end, and it would be 1 over n minus 1 over n plus 3. So that's basically the partial sums all added together to give us our series, our summation series. So what we're going to do now is we're going to rewrite that and reorder that to our benefit. So there's not a lot we can do to the half, so we'll just leave it there. There's not a lot we can do to the third or the fourth. So those 3 terms we're going to keep. But once we get to the next one, the 1/5, we certainly can group the 1/5. So we can group this 1/5 here specifically with this minus 1/5 here. We can do the same thing. We go to the 1/6. We can pair the 1/6 with the 1/6. We'll find here. So we've got that pair. And then we can go on. We can group the 1/7 with the 1/7. The 1/8 with the 1/8, and we can keep that pair going until we get to the end, in which case we would have 1 over n grouped with minus 1 over n. And if you look at the partial sum, that leaves only the 1 over n plus 3 on the end. So we'll just have to include that here on the end. So if we look at that partial sum, we can see that the summation will be the 1/2, the 1/3, the 1/4, plus, and now if you look at this part, will cancel, this part, this part, this part. So all the terms that we group together will cancel, and the only term we don't get to cancel is the 1 over n plus 3. So that's that. Now what we can do is, since this is going n is equal to 2 to infinity, we can take all of these are going to be convergent. So the first one's going to be 1 over 2, the second one's going to be 1/3, the third one's going to be 1/4, and as n goes to infinity, this one is going to go to 0. So it's just going to be 1/2, 1/3, 1/4, and so the original 2 times n equals to, sorry, we'll just correct that here, to 2 to infinity will be just these 3 constants. So it'll simply be 2 times 1/2, 1/3, and 1/4, which will be 13 over 6. We're done.